Alright, so today we're going to be looking at 3.2, which are properties of parallel lines. So we're going to be looking at those angles from yesterday and discovering some special relationships if we have parallel lines. That's kind of the key there. If I know that lines are parallel, some kind of special things happen. So let's look at the following corresponding angle postulate. Now, we learned pairs of corresponding angles and what exactly those are yesterday. Today, we're going to say, what if line L is parallel to line M? And so I'm going to denote this line L. I'm going to call this line M, and we're going to say that they're parallel. When I am drawing that they are parallel in a picture, I will draw a little triangle like that. Okay? So that means that those lines are parallel to one another. So if line L is parallel to line M, then corresponding angles are congruent to one another. So we know how to identify corresponding angles. What this tells us is that if those lines are parallel, they are also congruent to one another. So for example, let's look at all of our pairs of congruent angles if we know that corresponding angles are congruent here. So we know that 1 corresponds to 5, so that we know angle 1 is congruent to angle 5, because we know that line M and L are parallel to one another. So let's look for another pair. We have 2 and 6. So we know that angle 2 is congruent to angle 6. We can also say 3 and 7. So angle 3 is congruent to angle 7. And then our last pair, we know that 4 is congruent to 8 also. So 4 is congruent to 8. And now, see here how I only used one mark for both 1 and 4? They're vertical angles, so I know they're also congruent to one another. So by knowing corresponding angles, we can actually find out a lot of information. So now that we know theirs congruent, let's look at this example. We want to find the degree measure of all of those angles and explain how we got those. So the only angle we know here is this 55-degree angle. Well, if we know that angle is 55, we also know that the measure of angle 1 is 55 because those are vertical angles. So vertical angle theorem tells us that. So we know 1 is also 55. But then by the corresponding angles theorem, 55 corresponds to angle 7. So we also know that the measure of angle 7 is 55 because those angles are corresponding, and we know these lines are parallel. We have our marks up here that tell us that. So if 7 is also 55, then 5 must be 55 as well because those are vertical angles. Okay, so the vertical angle theorem tells us that those are equal. Okay, so we know all those are 55. Let's look at something else. How could we find out what the measure of angle 2 here is? Well, 2 and 55 are supplementary. They add to 180 together. So the measure of angle 2 must be 180 minus 55. 180 minus 55, if you do that in your calculator, is 125. So we know that the measure of angle 2 is 125. Because of that, we know that 4 must also be 125. Okay, so the measure of angle 4 is also 125 because those are vertical angles. Okay. So if 4 is 125, 8 is also 125 because 4 and 8 are in corresponding positions. They correspond to one another. So that's also 125 because of the corresponding angles theorem. And then finally, if 8 is 125, 6 must also be 125 because those are vertical angles. So that's the vertical angles theorem. So that is the corresponding angles postulate. It tells us if lines are parallel, corresponding angles are congruent. Okay, now let's look at alternate interior angles theorem. What that tells us is that if we have parallel lines, then we know that alternate interior angles are also congruent, which is very helpful. Okay, so not only are corresponding angles congruent, but alternate interior angles also are. Okay, so if line L is parallel to line M here, we know that what pairs of angles are congruent? Well, 4 and 6 are alternate interior, so we know that angle 4 is congruent to angle 6. And then we know that 5 and 3 are also alternate interior. So we know angle 5 is congruent to angle 3. Okay, so that theorem tells us that alternate interior angles are congruent to one another. So now let's look at same side interior angle theorem. Okay, so what same side interior angle theorem tells us? Well, let's look at these angles first of all. 4 and 5 are same side interior. Those definitely don't look congruent to one another. This one is acute, this red one up here, number 4, that's an acute angle. 5 is obtuse. So I know that they're not congruent, but they do have a special relationship. And that is that same side interior angles are supplementary. So they aren't congruent to one another. They add to 180. So we know that corresponding are congruent, alternate interior are congruent, and same side are supplementary. They add to 180. That's what that means. So for example, we know that if L is parallel to M, then the measure of angle 4 plus the measure of angle 5 has to be 180 degrees. Those have to be supplementary angles. Likewise, we know that the measure of angle 3 plus the measure of angle 6 is also 180 because those are same side interior angles. Okay, so for instance, if we knew that angle 4 was, let's just say angle 4 is 50, then we automatically know that angle 5 is 180 minus 50. So we know angle 5 here has to be 130 because those are supplementary angles. They add to 180 together. Okay, the last pairing of angles we're going to look at are alternate exterior angles. So let's look at those alternate exterior angles. We have, for instance, 1 and 7 are alternate exterior. Those are both obtuse angles. We can kind of see that. And so we can say actually that alternate exterior angles are congruent if lines are parallel. So not only are alternate interior angles congruent, but also alternate exterior angles are congruent. So for example, if L is parallel to M in our picture, then I know that both of my pairings of alternate exterior angles are congruent. So 1 is alternate exterior with 7. So I know that angle 1 is congruent to angle 7. And then I know that 8 is alternate exterior with 2. So I know that 8 is congruent to 2. Okay? So now let's put what we know so far, into practice a little bit and see if we can find the measure of all of these angles in this example. So the only thing we know so far is that this angle is 115 degrees. What I want us to do is find all the angles that are congruent to that 115. So let's start with corresponding angles. Do you see an angle that corresponds to 115? Well, let's look at angle 2. Angle 2 are in corresponding position on their parallel lines, so 2 must also be 115. Okay? But now let's look at where we can go from there. 2 is alternate interior with 3. See how those two are alternate interior together? So that means that 3 is also 115. And that looks like all the ones that I can probably say are 115. Now let's look at angle 1. Angle 1 is definitely not congruent to 115, but they form a linear pair. So I know that angle 1 is 180 minus 115, which is 165. Okay, so I know that angle 1 is 165 degrees. But look at angle 5. Those are alternate interior angles. So 5 is also, not 165, just 65, is also 65 degrees. Okay, but 5 is alternate interior with 4. So 4 must also be 65. And 4 corresponds to 6. So finally, 6 must also be 65 degrees. Okay, so it's kind of like a little puzzle that we're putting together with these type of problems. All right, let's look at these next two examples. We'll start with example 2. We want to find the measure of this question mark angle here. So the only other angle we have is 114. So the question really is, okay, sorry about the bell. So once again, we only have this 114 degree angle. So what we really need to determine is what is the relationship between that blue angle and the red one. Well, those are same side interior. Okay, those are same side interior angles. And we learned that if lines are parallel, which in this example they are, we have those little triangles telling us they are, that same side interior angles are supplementary. They add to 180. So that means that question mark plus 114, our other angle, has to be 180. Therefore, question mark is 180 minus 114. So finally, we know that that missing angle has to be 166. Oops, sorry, not 166, just 66. So our red angle here is 66 degrees, the one we were missing, okay? Because that is the angle supplementary to 114. All right, let's look at example 3. Now we're going to get a little bit of algebra involved, some x's. And I apologize if this is blurry and hard for you to read. That is 8x plus 14, and this is 102. So again, we have two angles. We need to figure out what is the relationship. So we have this 102 degree angle, and then we have this angle that we know is 8x plus 14. So what type of angles is that red and blue angle? What type of angle are they? Well, those are inside the parallel lines, and they are on different sides of the transversal. So these are alternate interior angles. And we just learned that if lines are parallel, again these are, that alternate interior angles are congruent to one another. So that means that 8x plus 14 has to equal 102. Okay, so now we have an algebra problem that we can solve. So that means 8x equals 88. So x here is 11. Whoops. So we know x is 11 there. So we've solved for x. So sometimes we're going to have a little bit of algebra problems mixed in with those. So the easiest way to do these is to identify the relationship you have. What kind of angles are they? And then you can determine from there if they are congruent or if they are supplementary. They're going to be one of the two. So the last thing we want to look at is these two examples. What I want you to do is pause the video and attempt these, and then I'm going to actually walk you through these still. So pause the video, try them out, but when you unpause, I'm going to actually work through those. Okay, so let's look at those, and I'm going to go through them kind of quickly, but if you have trouble with them, that's okay. We'll go over them in detail tomorrow in class if you need to. So here, these angles are alternate exterior, meaning that they are congruent to one another. So I know that x squared equals 54 plus 3x. So what I need to do now in order to solve this, since I've got a squared value, I'm going to have to factor. So what we need to do is get everything onto one side. So that will become x squared minus 3x minus 54 equals 0. I just got everything onto one side of the equation. Okay? And so now we need to factor this. Since I've got minus minus, that my answers are going to be plus minus. One's going to be positive, one's going to be negative. So now I just need to look for factors of 54 that will work for me. So some factors of 54, well, it breaks into 18 and 3, but even if 18 was negative and 3 was positive, that would not equal negative 3. That wouldn't work. I'd get too big of a number from that. So it also breaks into 9 and 6. So if I do negative 9 and positive 6, that will equal negative 3. So those are the guys I want. So I know that a 6 needs to go here, and that a 9 needs to go here and be negative. Okay, so my solutions will be x equals negative 6 or x equals positive 9. And either one of those will work because neither, when I plug them in, gives me a negative answer. And so finally, let's look at example 5, and we'll be done. So the relationship in between these two angles here, those are same side, and they are interior of the parallel line, so they add to 180 with each other. So I know that 2x plus x minus 12 has to equal 180. So I know that 3x 12 equals 180. So 3x equals 192. So x here has to be 64. So now I just need to find y. So let's look at y. Those two angles with y in it are also same side interior, meaning they are supplementary with one another. Okay? So I also know here that 3y plus y plus 20 equals 180. So 4y plus 20 is 180. So 4y equals 160. So finally, y has to be 40. So I know here that x is 64 and y is 40. Okay, so I know that those were a little bit harder. Don't freak out about that. Your ones on your homework are not quite that bad. You have a few factoring and you have a few like example 5, but I will help you through those. So see you in class tomorrow.